Well, we're ready to move on to chapter 12. And in chapter 12, we actually only do a few sections, starting with 12.3. We're going to simplify rational expressions. So it might be helpful to know what a rational expression is, so make sure you have these definitions in your notes. Rational expression is just an algebraic expression whose numerator and denominator are polynomials. So a rational, that means we're dealing with fractions, and our fractions will look like polynomials. So for example, maybe one could be 2x plus 5 over x minus 1. You have this binomial on top, polynomial, over this binomial, two-term polynomial on the bottom. So problems that look kind of like that. When we deal with fractions, we need to know about excluded values. So excluded values will be any value that makes your denominator equal to 0. If you remember in math, you cannot divide by 0. That's when things are undefined. So we have to exclude any values to avoid dividing by 0. So a really basic example would be, let's say that our rational expression was 2 over x. Well, anytime you use a variable, you're saying that x can be any value. You know, all your negatives, all your positives, zeros, all that stuff. Well, as soon as you throw an x in the bottom of a fraction, we have to think about what numbers you cannot divide by, and 0 is the only one. So here would say, well, x just cannot equal, so x does not equal 0. That's our excluded value, and that's how we would write that. So they're not all that basic, but that gives you the basic idea. All right, this slide I'm going to skip because these examples are in the next video you'll watch, so just make sure that you do actually listen to the whole video. Don't just try the problems and skip over the explanation. All right, so I'm going to move on to simplifying rational expressions. So what we're going to do is simplify these fractions. If you notice, these are monomials. It's a monomial over a monomial. There's no plus or minus signs. So when your rational expression looks like these, you're just going to go left to right, kind of step by step. So first look at, you have a 6 over a 2. Well, 6 over 2 you can reduce to 3 over 1. Now we're going to look at the x's. You have x to the third over x to the fifth. Now, when we've actually done these before, in chapter 7, our exponent property, we know that when you divide the same x's or the same base, you subtract your exponents, so 3 minus 5 is negative 2. Well, is this okay for our final answer? Probably not, because you've got this x to the negative 2, which means that's going to come down here to the bottom. The 3 stays on top, and the x to the negative 2 becomes a positive 2, and there's our final answer right there. So hopefully these rational expressions, when it's a monomial over a monomial, will seem very familiar. All right, the next one, first we're going to look at the 15 over 5. That reduces, if you divide by 5, to a 1 over 3. And then when you divide your x's, you're going to subtract. 2 minus 1 is x to the first power, and that's positive, so that can stay. So if we clean that up a little bit, 1x to the first is just x over 3. All right, so now we have to talk about how do you simplify rational expressions when there is more than one term, if you have binomials or trinomials. So it's very tempting to try to cancel out some x's and maybe, I don't know, divide some 25s down here. Here's the thing, if you have a plus or minus, what that does is it kind of glues these terms together, and it glues these terms together. So I can't cancel this x squared because it's connected to the x. The only time that you can cancel things is when you separate with multiplication. So how do we get around simplifying these expressions? We are going to factor them. It's all about factoring. So we're going to factor every single thing we see. So this first example, in the numerator we have x squared plus x. So that's just a binomial. We can take out our GCF of x, and it leaves us with x plus 1. All right, our denominator, we have 2x plus 2. So let's go ahead and take out the GCF there, which would be a 2, leaving us with x plus 1. All right, so what we notice here on the numerator is x times your x plus 1, and on the bottom, x times that, or 2 times the x plus 1. So what we have is this x plus 1 being divided by itself, x plus 1. This is kind of the fun part. This is where you get to cross them off, because x plus 1 divided by x plus 1 technically equals 1, so we can cancel those away. So then we look and we see, what do we have left over? You have an x in the numerator and a 2 in the denominator, so that will be our final answer. So what we're doing is we're factoring everything and then looking to see what we can cancel. All right, next example, numerator x plus 1 can't be factored. There's no GCF, so that's going to stay the same. Now the denominator is a trinomial. You got x squared minus 4x minus 5. So remember, anytime it's just an x squared, we get to do our simple trinomial factoring. Go to the last term of negative 5. So we're looking for factors of negative 5 that add up to the negative 4. So we'll think about all the factors and we're going to come up with negative 5 and positive 1. So when we factor it, we're going to have x minus 5 and x plus 1. So looking at that, you might notice you have an x plus 1 on the top and an x plus 1 on the bottom. So we get to simplify the rational expression by crossing those off. So the x minus 5 that's in the denominator has to stay down there. And because we canceled everything out from the numerator, we're going to leave a 1 up there. So we have 1 over x minus 5. All right, next example, we have x squared minus 25, so that's 2 terms with subtraction. That's our difference of squares pattern. Factors into x plus 5, x minus 5, over, now the denominator we have x squared plus 10x plus 25. So start with 25, and we're looking for factors of 25 that add up to 10. And that's just going to be a 5 and a 5. So when we factor that, we have x plus 5 and x plus 5. So we look to see if there's anything we can cancel away. This x plus 5 will cancel away one of the x plus 5s. It's like a 1-for-1 deal. Now it might be tempting to try to cancel something with what we have left, but this is x minus 5 and that's an x plus 5, so they're not the same. And remember, we can't cancel the x's because this x is glued to the 5 with that subtraction, and this x is glued to the 5 with the addition. So our answer is just going to be x minus 5 and over x plus 5. So be really careful about that temptation to cross off x's or reduce 5's. The plus or minus signs in between your terms keeps us from doing that. We cannot do that with the plus and minus signs. All right, this is the last slide of the intro video, but again, there's one of the videos you'll be watching covers these 3 problems, so just make sure you listen carefully and take really good notes on all of the remaining videos.